At what temperature would 2.2 moles of a gas occupy 67.5 liters if the pressure is 115 kilopascals? And we're solving for temperature. So here's our ideal gas law, PV equals nRT. So let's go ahead and write out all of those variables and figure out what all of our values are. So we have 2.2 moles, that's going to be our N. 67.5 liters, that's a volume. And a pressure is 115 kPa. And we're solving for temperature. So the only thing we don't have is our R value. So these are the three different options that you see in your reference packet, and they differ only in the unit that is used in pressure. So if you look, it has liters for volume, moles for the amount, and Kelvin for the temperature, but that unit for pressure is going to change. So you basically are going to pick the one that matches whatever unit of pressure that you are dealing with. And in this case, we're dealing with kilopascals. So that means we're going to use this R value. So our R value is going to be 8.314. So now all we have to do is substitute all those numbers into our equation. X is our temperature, and now let's simplify this a little bit by go ahead and multiply those numbers. And now to get X by itself, we're going to divide both sides by that 18.29. And we get an answer of 424.4. Since we're solving for temperature, that's going to be Kelvin. Let's go ahead and look at another one. So what is the volume of a gas at 50 degrees Celsius and 0.8 atmospheres if there are 0.75 moles of the gas present? And this time we're solving for volume. So again, writing out my variables. 50 degrees Celsius is our temperature. We need to convert that to Kelvin. 0.8 atmospheres is our pressure. 0.75 moles is our amount. And volume is what we're solving for. So again, we need to figure out that R value. This time we're going to pick the one that matches atmospheres. So we're going to use this first one. So this time our R value is going to be 0.0821. Let's go ahead and plug those into the formula. And we can go ahead and multiply all of those. And to get X by itself, divide on both sides. And since we're solving for volume, that unit is liters. One more example. This one says, at what pressure would 0.8 moles of oxygen gas occupy 7.5 liters at a temperature of 375 Kelvin? So this time we are solving for pressure, and specifically it asks for pressure in torr, and that is important information. So let's look at our formula. So to figure out our R value, we need to think about our pressure unit. Well, this time we're solving for pressure, but it does ask us to have the units in torr. So in this example, we need the pressure unit that matches for our R value. But what you'll see is that there isn't an option for torr. But the reason for that is because torr is the same thing as MMHG. It's just two different names for the same unit. So we are going to use that middle value, 62.4. So now let's plug all those numbers in. So our answer is 2,496, and our units are going to be torr.